Today we are learning how to solve basic cubic equations or equations where the highest exponent is a 3. Remember, it's called cubic because when something's raised to the power of 3, that's the same as like having 3 dimensions, like a cube does. I would recommend knowing the first 12, at least, perfect squares, and the first 5 perfect cubes. It's even more helpful if you know more, but that helps you a lot with the equations that we solved yesterday and the equations that we'll be solving today. Now, just remember, the square root of -4 or the square root of any negative number does not exist. And in math, we write it DNE for does not exist. The reason why is when you multiply a positive number by itself, you get a positive number, which is not -4. And when you multiply a negative by itself, you get a negative number. So there's not really a way that we know of that you can multiply a number by itself and get a negative number. So anytime you have a square root of a negative number, you don't even have to do the math. We are solving equations using inverse operations. Let's talk about the ones that we know. You have been working with addition, subtraction, multiplication, and division for a while now. And the inverse operation of addition is subtraction because it undoes it. And then addition undoes subtraction. And then division undoes multiplication, and multiplication undoes division. What's kind of cool is that you can see that they usually kind of come in pairs, like these two things undo each other. Now we are working with squaring, and what undoes squaring is the square root, and cubing, and what undoes cubing is the cube root. There's another thing that you'll work with more next year. We've worked with distributing or the distributive property, where multiplication distributes over addition. You've probably seen it like this. And what undoes distributing is factoring or dividing everything by the same number. And sometimes it can get a little complicated. So today we are working with cube roots and cubing. We're going to go ahead and solve this equation. It only has one operation done, so we just have to do one inverse operation. And the inverse operation is taking the cube root. So I get x, because remember the cube root and the cube undo each other. It's as if neither were done. So x equals the cube root of 8. You should have this memorized, but the cube root of 8 is 2 because 2 times 2 times 2 equals 8. And before, when we were solving with quadratic equations or equations that have squared variables, we had to write a plus or minus at the end. But here, we actually won't need one. So you won't need to write this any time today. And the reason why is if you look, a positive cubed, that equals a positive. I feel like that one's not a surprise. But a negative cubed, what does that equal? A negative times a negative equals a negative. A positive. So a positive times a negative equals a negative. So a negative cubed equals a negative. So let's write that down. When we cube a positive, we get a positive. And we cube a negative, we get a negative. So today, you won't get the same answer by cubing a positive and a negative, so you only need one answer. X equals 2 is correct. There's only one thing cubed that equals a positive 8. Let's go ahead and do some examples. On ones like these, all you have to do is take the cube root. It's pretty easy. So you can plug that in your calculator, or hopefully you know that -1 times -1 times -1 equals -1. Or you know 1 cubed equals 1, and you can just add a negative on it. Okay, this one, let's take the cube root. This is not one of the first 5 perfect cubes, so I'm going to go ahead and check this out. Be careful not to use this button, because that says it's 14.69, blah, blah, blah. Make sure that you find where the cube root is. You might have to research where that is on your calculator. And this says the cube root of 216 is 6. So I get y equals, because those were inverses, 6. Okay, this one's a little fun. Now this is actually 2 operations. If it were like this, that's something different. But this has a negative multiplied by p cubed. And the way you can tell is there's always a coefficient of a nice skinny 1, and a number next to a variable is always multiplication. So we're going to do, just like we've been solving equations this entire time, we're going to do PEMDAS, but backwards. So this says that addition and subtraction should go first. I don't have any of those. It says multiplication and division should be undone next. So I'm going to undo multiplying by -1 by dividing both sides by -1. And I get p cubed equals, well, dividing by a negative just makes it positive, and then dividing by 1 really doesn't do anything. You could plug that in your calculator too if you're unsure. So now let's take the cube root to undo this last little exponent here. And when you plug in the cube root of 1 million in your calculator, cube root, so I need a little 3 and then 1 million. How many zeros were there? 6. Okay, so I have 1, 2, 3, 4, 5, 6. Oh no! So if you notice, 2 of those zeros are outside of the square root. You want to make sure that everything is under the square root bar. So let's go back and see if I can fix that. And I get that it's 100. And it's all under the square root, so that should work. You can always check your answer and plug in 100 cubed and see if you get 1 million. So we have one answer. Remember that all of the ones for today will just have one answer. Whew, this one looks like a doozy, but let's write our PEMDAS here and do it backwards, our SADMEP. The first thing I should undo is addition and subtraction, and I see I did subtraction, so I'm going to undo it by doing addition. And I get 14m cubed equals. That looks like 378. Okay. Next thing I should undo is multiplication and division. 14 is multiplied. Anytime you have a number next to a variable, that's multiplication. So I'm going to divide by 14 on both sides. I get m cubed equals, I don't know what that is. Let's do 378 divided by 14. Ooh, 27. That's a nice, pretty number. Okay, last step. That's this exponents right here. Let's undo the exponent by taking the cube root. And I get m equals 3. Hopefully you know that the cube root of 27 is 3. All right, so basically we're doing the same thing. We're doing PEMDAS backwards. And what's different from quadratic equations is now we only have one answer to each equation.